Now, a virtual machine is not the only option if it comes to running programs, especially websites. There is also something called a web app. So a web app is a higher level of abstraction. You are not so much dealing with the underlying servers and backups and all of these things. The options you have in terms of server level options are more limited, but it is actually give you a lot more flexibility and options in terms of working with your apps. So with a web app, you're basically just deploying your zipped up code and configuration files into Azure, and Azure will execute that. And so it's a platform as a service. I'm going to say create under web app. Now I'm going to put this in the same resource group in new VM2 we were just working with, just for the sake of keeping them everything together. Now when it comes to web app name, it is a globally unique requirement. So there's this .azurewebsites.net URL that you are setting at the same time. So the name that I choose is got to be something that no one else has used. Another unique thing about web apps is that you have options when it comes to whether you're deploying specific runtime code. So .NET Go, which is a new option, Java, Node.js, PHP, Python. These are some of the options. There is such a thing as a custom handler. And so if you have something outside of this that you want to do, you can choose a custom handler. We also have the option of deploying a Docker container, an image, or a static web app. So we're just going to go with the code option for convenience. You still do get the choice of operating system, Windows or Linux. It can matter, even though something like .NET is cross-platform. Region, same deal as the virtual machine. The region does matter. You want to place it closest to your users, and it also going to have different pricing depending on which region you choose. There is a free option. So you can deploy into this F1 plan, which is a shared plan. I'm going to give this a new app service plan 1, 2, 3. Or you can choose from one of the paid options. Let's say explore pricing plans. So we can see that there's the free option, or there's a shared option, D1. And if you want to get into more standalone plans, you've got basic, standard, and premium. And there's many different flavors of premium, as well as isolated if you have isolated hosting. We see there's popular options, or you can break them down into dev test or production or isolated. So if we look at dev test, we can just go with a basic B1 plan. Now, and we're not choosing CPUs, we're not choosing which hardware is running underneath, but Azure does give us a relative measure. So this ACU, or Azure Compute Units, gives us a way of measuring what the performance is between two plans. So for instance, the standard S1 plan has 100 ACUs. The premium V3 plan has 195, so almost double. And if you get into premium V2 P1, it's 210. So you got a couple of different options for performance. We're going to go with the basic plan, of course. We can see the CPUs, the memory. That's what this refers to, but not the underlying hardware. We can also see the pricing. So a basic B1 runs you about $70 a month. We can deal with redundancy in the premium option, but not at the basic option. Probably you could do it, yeah, at the premium option, but not basic or standard. Now, if you want to hook up GitHub so that there's a continuous deployment happening, you can certainly hook up your GitHub account and get something that's, once you push it to GitHub, automatically deploys. That's a common configuration. You can enable public access, so anyone on the world can access this app, or turn that off and make it so that it's attached to a specific virtual network private to Azure. We'll skip over that. We'll skip over application insights for now, which is a monitoring option. Skip over tagging, and we'll go directly to review. So now we can see it's $75 a month and say create. So we'll let that run and take a look at it in a second. So that was another quick deployment. And if we look at the deployment of the operation, 30 seconds, right? So we're going to say go to resource. Now, like I said, a web app is sort of an abstraction of a virtual machine. You have the computing power, but you're not really controlling the machine to the same degree. We're going to set up some settings here and configurations, but we are not remote desktoping into the operating system and installing our own software. We're not managing IIS in any way, but we do have settings within here. So we can see that we have a running app service. It was a B1 plan. We have only one instance running. I'll talk about that in a second. It is a Windows machine running in East US. And we can look at various things that we can do. Let's look at how we can change our mind and go to a bigger plan. So there's two concepts with web services called scaling up and scaling out. So if I go to the scale up option, this is where I can change my mind and go from the basic B1 plan up to, let's say, the S1 plan. So I want to go to the full-on standard settings, and I can say select and say upgrade, and that will then take me away from the basic plan onto the standard plan. We can see that the app service plan pretty instantly was switched over from B1 to S1. Microsoft pretty much has these instances ready to go, and we can then switch between them. Okay, so if I go back to the overview, we can see that the app service plan is now S1. The other scaling option is the scaling out. And this is the concept of having multiple instances of the web server running. And so on our standard plan, for instance, we could have either manual or rule-based scaling. Manual scaling is just as it sounds. Right now I'm running one web server. If I wanted to, I could run two. And I can say save, and suddenly I have twice as many web servers listening for requests and serving customers. And that's just a manual scaling. There's no rules to it. It's not going to go up or down. It's just now two. The other option I have is what's called auto scaling or rules-based. So rules-based scaling we ignored if automatic scaling. Now, there's a new one called automatic scaling where Microsoft will take care of scaling. It'll anticipate that you're going to need scaling. We're talking about rules-based scaling here. And if I go under what is called auto scaling or rules-based scaling, I choose custom auto scale. Right now I have two instances running because I manually scaled it. I can set some rules to scale based on, let's say in this case, scale based on a metric. And if I wanted to, I can scale based on CPU, for instance. So if I want to check if the CPU percentage is greater than 70%, then I want to add an instance. So increase instance count by 1. And if you're going to have an auto scale rule to scale up, you should probably have an auto scale rule to scale back down. So in this way, so I'm going to say we're less than 20%. So if the instances are less than 20%, it's going to decrease the count by 1. So in this way, Azure is going to add instances and subtract instances based on particular CPU. Now, right now, I don't have a minimum and maximum set, so I can say minimum 1, maximum 10, default 2. So if I said save to this, then Azure is going to take care of adding additional capacity and taking away capacity when it's no longer needed. So yeah, that's the concept of auto scaling. Now we don't really have the option to remote desktop into this machine like we do, but we can access the underlying operating system or underlying hard disk based on FTP. And we can also access a console. So by going on our development tools console, I can see the C drive. And if I say dir, it will show me that there's only a single HTML page there. It also supports Linux commands like ls. So both of them would work in this console. Another cool feature of app services is the concept of a deployment slot. So depending if you're on a basic or standard or premium, you get the choice of having additional places to deploy to. The advantage of this is you're going to have a production slot, and then you could have, for instance, a staging slot. And this is going to give you a unique URL that you can access, which might be your test version of your app. And then when you're tested it and you're happy, you think this is working great, you can swap the staging slot with the production slot, and they'll take each other's place. Staging becomes production, production becomes staging. So deployment slots is a way of having multiple running versions of your application and then being able to swap between them when you're ready to make the test version production. This also supports a type of A/B test where you can send, let's say, 10% of your traffic to one version of your app while 90% of your traffic stays with the main version. You can see how effective this is if there's any bugs introduced. Maybe you're testing certain SEO features, click-through rates, conversion rates, things like that. You can do A/B tests to see if your application is an improvement without having to send all your traffic to there. So web apps is a pretty cool concept when it comes to hosting applications in Azure without having to manage the underlying virtual machine like you do in a server environment. So in this video, we're going to demonstrate the other type of compute resource in Azure in terms of Azure functions. As we saw in our previous section, we have many different types of compute resources, including virtual machines, web apps, containers, and so I'm going to demonstrate to you how to work with a function. So I'm going to go into create a resource, and we're going to see function app is on the list of most popular services. So I'll just create it from there. Say create. Now we need to create a resource group for, as usual. So I'm going to create a brand new resource group for me. And the function doesn't need a name. As you can see, it has got a domain name extension, .azurewebsites.net. So this needs to be globally unique. And I just have to hope that no one else has chosen this function name anywhere else within Azure, and the green check mark tells me I'm fine. Now, one of the things that makes functions interesting is that you do have a couple of different ways to deploy code. You could work on your local machine to develop some code and deploy it as a container. In the next video, we're going to deal with container instances and then eventually container apps. So we'll skip over this for functions, but let's talk about the code options. Microsoft Azure gives you 6 built-in languages that it supports: .NET, Node.js, Python, Java, and PowerShell. And if you have any other code that you want to run that is not one of these languages, then there is this custom handler. So you could also deploy, if you have a PHP script, you could deploy a PHP handler, DLL, and then you could run your PHP because you've got the handler included. But we're just going to stay simple. I'm going to check the JavaScript option, which is Node.js. You do get choices of versions, so I'll just leave it with the default. You do get the choice of region, just like with any other service within Azure, loaded in North America, Europe, Asia, any of the ones that you have access to. I'm going to leave the default for me. You do get the choice of operating system. Now, this might be more relevant if you're using the custom handler, but if you're not using the custom handler, you still get the choice between Windows or Linux if it matters to you. Depends on your script, obviously, if it needs the underlying operating system for anything. Now, another of the interesting features of functions is you get a choice, what is called a hosting plan. And effectively, this is how you're going to be charged, how your app scales, what features are enabled, and how it's priced. Now, the consumption plan is what really makes functions interesting, and you can see it says serverless. So this is an example of a serverless option. So really, you're just working with the code, you're uploading your zip file, uploading your configuration parameters, and Azure is taking care of everything else. You don't know what hardware it runs on, whether it's one server, two servers, five servers, it's out of your control. You're paying for executions, and this has quite a generous free level. So we are eventually going to choose the serverless option. Now, there is a premium option, and it's going to include preemptive scaling. If you know that something's going to happen and you need to scale, you could do that with premium. Being network isolation, so you could have isolated functions running on your own hardware. If you have functions that are running continuously, then you might want to consider the premium option. Finally, you could operate similar to an app service, and you'll just install your function on an app service plan. Again, that'll be priced similar to a web app, which will be $80 a month, $160 a month, something like that for your function. I'm going to go with the serverless option. I think it really takes advantage of one of the big features of functions. Microsoft's going to take care of scaling it. And again, it's very competitively priced. I think it's extremely cheap. As long as the functions are not critical to your functioning of your organization, in which case you might have to pay a little bit more to get premium level functions. Now, a function needs a storage account. It's mandatory. The function files are going to be stored somewhere, so it's going to create a new storage account for me. You do have the option of turning off public access and attaching it to a virtual network, but you have to be on premium or on app service plans in order to do networking options. Public access is fine. We do have additional security measures, even with public access, so you'll need a security key, a host key, or a function key in order to access your function, even on the public access option. Turn off monitoring for now. We're not going to really concern ourselves with this. Now, we could connect this to GitHub, and then we would work with our function on our local machine, push the code into GitHub, and then have that auto deploy, what is called continuous deployment. It's good for a development environment for sure, but we're going to disable that for now. We won't set up any tags. And I'm just going to say review and create. And so we're going to create ourselves a function, a Node.js function, which is a JavaScript language, and the consumption model, which is priced for usage. So how many executions you have, how much CPU your executions use. I'm going to pause the video. We'll let that deploy. All right, that deployed pretty quickly. Let's go into the function. Now, this is just the function app. We actually haven't created any code yet. Now, one of the interesting things about functions, another interesting thing, is that you can create the function right within the portal. So you do not need to have Visual Studio or VS Code running or some other editor. You can create a function using the portal, and I'm going to click that option. So it says development environment, develop in portal. So I'm going to choose an HTTP function. Remember, in the video on functions, I said that you could have a number of triggers, and there are a couple of dozen of them. One of them being on HTTP request, another being based on a timer, Azure Queue, Service Bus, Blob Storage. Lots of different things can cause a function to execute. Now, if I scroll a little bit more, I can see the name of the function. So this is going to be Scott Demo. Now, there is a security setting. We can allow anonymous functions, which means anyone can access this function without a security key. Or we're going to require either a function level key or a min level key. I'm just going to leave the default and say create. Now, once the function itself is created, Scott Demo, I can go to code, look at the code right within the browser window, and modify the code. I'm going to minimize this window here. This function is pretty straightforward. It is looking for a query string, which is a parameter passed as part of the request. So it's either looking for a query string with the value of name or a body request with the value of name. And then it's going to say hello with the name. So I'm going to copy this URL. You can see get URL. I'm going to get the function key that is called default, and I'm going to say copy. And then I'm going to open a new browser window, and I'm going to say paste, and we're going to load it up. Now, right now, it says HTTP triggered function executed successfully. Pass a name in this query string in order to have a personalized response. So to get to the query string, I just need to go to the URL and add an ampersand, and then I can say name equals, and then give it a value. So I can say Scott and hit enter. And now it says, hello, Scott. This function executed successfully. And so that's the code of the function that is executing. Now notice I didn't have to create any servers. I didn't choose an A2 server, a D1 server, a B2MS server, anything like that. It's simply taking the code and running it. Now, again, this is a very cheap way to do it. You can execute this function or a function like this 1 million times in a month under the free plan. So if you've got some little piece of job that needs to run, some file that needs to be moved, some email that needs to be sent, some message that needs to be added to a queue or read from a queue, you can do that in a function. At least consider doing that in a function. So we saw how easy it is to create a function working right within the browser on a serverless consumption. So in this video, I'm going to demonstrate to you the way to use containers within Azure. Now, when you look for them, you're going to find that containers are actually all over Azure. You could have containers running in functions. We just saw this in the last video where you could have deployed a container to a function. You could have containers into a virtual machine. We could install the Docker software to run containers on a virtual machine. Web apps also supports container images, Service Fabric does, etc. So there are so many different ways to deploy containers. But we're going to talk in this video about 3 services that are specifically designed for supporting containers and not are supporting other things including containers. So I'm going to go into create a resource and I'm going to go into containers. Now, the largest service is called Azure Kubernetes Service, or AKS. Now, this is often called enterprise-grade containers. It's designed to run on a group of servers called a cluster. So you can't run Kubernetes on a single computer. You need at least 2 computers, 3 computers, maybe more, in order to run an application in Kubernetes. And so this is a really complicated, complex piece of software. But it could be great if you are working at enterprise scale. If you are an enterprise such as Microsoft, Amazon, Google, Facebook, etc., and you need to run applications, you're going to choose a service like Kubernetes. Kubernetes is what's called an orchestrator, in that it's like the traffic cop that runs the containers, makes sure that they're running, adds more if more are needed, directs the traffic, etc. So orchestration is a big feature of Kubernetes. Like I said, you could run them in a web app. The one I'm going to talk about in this video is called container instances. Now, I'll talk about container apps in the next video, but container instances is the smallest, quickest way to deploy a container. So I'm going to click create on that. So container instances are really designed for very specific purposes. And these are sort of low priority jobs, or if you're testing something or demonstrating something, or it's not mission critical that this job execute, you can run your containers in a container instance. It's not great at scaling. It doesn't have that type of orchestration, multi-nodes, multi-clusters, things like that. So ACI demo, I'm going to call this. So it's great just as a standalone container instance. We have to give this container a name. So I'm going to call this ACI demo. Hopefully no one has taken that. It's going to run in by default region here. Now we do have the option, this is in preview mode, but we can deploy our containers into multiple zones within a region if we do really want to talk about enhanced availability. There is the standard SKU, and there's also this confidential policy. This is an advanced feature. You're not going to see confidential container instances on the exam, so we'll just stick with the standard. Now I'm going to use a demo image. Microsoft does provide 3 examples of a web server, Linux server, Windows server, and then a Hello World as a Linux image. And so I'm just going to choose the Hello World instance. Now, if you've got your own images, you might want to choose Azure Container Registry. Or you could have some Docker Hub or some other third-party registry, right? So we're just going to get the quick start and we're going to choose the Hello World. You can see that it's chosen me fairly underpowered instance, which is 1 CPU and 1.5 gigabytes of memory. So that kind of shows you the type of images that you want to deploy to a ACI instead of real enterprise grade that you go to Kubernetes. We also have these familiar networking options that we did for web apps and for functions. We'll just keep this as a public function accessible from anywhere. Public container. And then we also get to choose what happens when it fails. So do we just restart the container when it fails? We can set some environment variables if we wish. We're going to skip over this. It's too advanced for this. And we're just going to say create. So we're going to see here, it's going to create me an Azure Container Instance using this Hello World image from a public repository that Microsoft provides. And again, if we were to try to deploy something similar into Kubernetes, we would see how much more complicated it is. So we'll just do this demo real quick. All right, so let's see how long that took. Operation details, 36 seconds. So you could go from having an image deployed to your Azure Container Registry and then get that into a running in Azure code in 30 seconds. That's pretty good. So I'm going to say go to resource, and it's going to show me all of this information. I don't currently have a fully qualified domain assigned to this yet, but I can copy the IP address, and I can paste this IP address into a browser window, and it says welcome to Azure Container Instances. This is the Hello World for this app. So you saw that it was very quick and simple to deploy an image into a running code on Microsoft Azure using container instances. Now we can see on the container settings that we have activities that happen, pulling the image out of the Microsoft Container Registry and how the container started. We can see what's happening. We can check in on some properties for this, real-time logs. So if we're trying to debug it, we can see what's going on. So that's the ACI demo. In the next video, we're going to go a little bit more complicated, not too much, with Azure Container Apps.